Hello everyone, thanks for having me. I'm Anthony O'Riordan, I'm the Managing Director at Kaizen PLM, and today we're going to speak about Directed Energy Deposition Programming with Siemens NX. Before we get into the technical detail, I'll just give you a little introduction as to who Kaizen PLM are. We're a Siemens Industry Software Gold partner and we operate within the Ireland and UK markets. Kaizen PLM were also the first accredited Siemens additive manufacturing smart partner globally. We're uniquely positioned to provide Siemens virtual commissioning solutions also, and that's due to our partnership with our sister companies Underwoods and Park Electrical Services, who are the UK's biggest Siemens factory automation partner. The team at Kaizen PLM are all engineers, and the team consists of experienced mechanical, electrical, and PLM engineers, and we use our skills to support the deployment of software for mechanical and electrical design, manufacturing planning and simulation, along with component and system level physics simulation. Some of the services we provide can be seen here. We obviously sell and support Siemens' broad range of software solutions, but we also provide engineering consultancy, design services, and training on all of the software packages. We also develop post-processors for subtractive and additive machinery, along with virtual commissioning services. And our products and services are built around the Siemens Digital Innovation Platform. So Siemens is a name that many people know. They're Europe's biggest engineering company, but some people don't realize that they're also the world's biggest engineering software provider. So the Digital Industries software division of Siemens has approximately 40,000 staff, and approximately half of those staff are involved with software product development. So every day there's around 20,000 people focused on developing the broad range of Siemens software products. But today we're mainly going to be focused around Siemens NX, which is part of the mechanical design platform. But Siemens NX isn't just a CAD tool, it also does 3D physics simulation and computer-aided manufacturing. So now, the way forward when it comes to manufacturing is highly flexible and autonomous advanced manufacturing systems. Mass production started over 100 years ago. Manual labour was performed on static assembly lines, and people worked on parts, sub-assemblies to manufacture the final product. Automation then came afterwards, which freed humans from performing tedious and repetitive labour. On the other hand, automation has been functioning the best in a fixed setup. When the product changes frequently or the parts are flexible, manufacturers usually go back to human operation to keep the flexibility. Moving forward, a flexible and autonomous production system will become the holy grail of all manufacturing companies. This is one of the main advantages of multi-axis additive deposition. In its ideal state, it will be a fully flexible and fully autonomous process. As you might know, the overall CNC market is projected to grow over the next 6 to 7 years at a healthy rate. This is largely due to the growing demand for more efficient and more complex multi-axis machines. One of the fastest growing segments of the multi-axis market is hybrid manufacturing. In fact, the market for hybrid, additive, subtractive machines will grow twice as fast as the overall CNC market. Of course, the primary driver for increased usage of hybrid manufacturing is the growth of metal additive manufacturing, which is growing at nearly twice the rate of the hybrid additive manufacturing market. So why should you drive your multi-axis additive manufacturing machines with Siemens software? Well, in order to control your multi-axis deposition machine, whether it's a gantry-based or a robot-based system, you are going to need an offline programming software. You need this to handle complex 3D geometries, to create and optimize toolpaths in a virtual environment, to simulate and validate the entire manufacturing process, including your part orientation and your deposition strategies. The software can also be utilized for resource optimization. The software assists in optimizing the manufacturing process by selecting the most efficient and effective parameters for deposition, such as layer thickness, deposition speed, and material usage. This ensures a higher quality final product, and it also ensures reduced waste. A post-processor is also an essential component within the offline programming software, and the post-processor acts as an intermediary between the software and the specific multi-axis deposition additive manufacturing machine. The post-processor translates the toolpath and the manufacturing instructions generated by the software into machine-specific code, typically known as G code or M code. And this code can be read and executed by the machine's specific controller. So we can conclude that companies need software to drive their new multi-axis machines. Often they try to get by with just 3-axis milling software and some rotary tables to achieve the additional degrees of freedom. This would be known as 3+2 CAM. But without full 5-axis CAM, companies compromise quality and efficiency. 5-axis machines need to maintain continuous contact between the tool and the workpiece, which leads to better part finish, less scrap, and ultimately less human interaction and higher efficiency for the business. So, given the trend towards multi-axis machining and hybrid manufacturing, what do you need from the actual software that drives these complex machines? Well, first and foremost, it has to have all the capability to get the job done, and that means it needs to enable proper material coverage, better handling of overhangs, consistent bead thickness, better sidewall finishing, superior surface finish, and doing all of this simultaneously is key. But beyond functionality, if you are considering hybrid manufacturing, the multi-axis software for your machines should connect seamlessly within an industrialized additive manufacturing workflow. That means that there should be a unified associative digital environment from design and part validation through to part build preparation and simulation, to 3D printing, follow-on machining, process monitoring, and quality control. The Siemens NX environment allows you to do every step of this process in one unified software workflow. And a good offline programming software will also need to support multiple technologies. Siemens NX has all the capabilities that you need for a multi-axis additive or a multi-axis subtractive operation. In terms of additive, we support laser metal deposition, material extrusion, electron beam, wire arc, and cold spray technologies. And a good offline programming software should also do more than just CAM. An associative CAD and CAM process is essential. And here you can see some typical steps in the process. First, you will design your hybrid part using ideally one program with one user interface, which makes for a simplified workflow. Using one program instead of transferring files means parameters, feature trees, and associativity remain intact, keeping the engineering intent in one file. Then you will use integrated design checks to validate its manufacturability for that given manufacturing process. You can analyze part thicknesses, overhangs, tool axis orientation, and other properties to determine if the part is manufacturable from the 3D CAD data. You can confirm that the part can be built within the kinematic reach and limits of your individual additive machine. Then you will probably need to use advanced CAD tools to easily separate the geometry into separate bodies, allowing you to apply different additive deposition strategies to each part. If printing using multiple materials, you might want to separate the features for each material type as well. Then you will apply your additive deposition toolpaths, and you might also want to program your subtractive machining toolpaths for post-deposition machining. Simultaneous 5-axis machining allows for the creation of complex shapes like impeller blades or heat exchanger vanes. Siemens NX allows you to simulate the additive and subtractive machining operations with full G-code simulation. G-code simulation is a process that allows users to virtually visualize and verify the toolpath generated by G-code instructions, which are used to control CNC machines. This simulation helps identify potential errors, potential collisions, or potential inefficiencies in the machining process before actual production, which obviously saves time, material, and costs. Siemens also provide the hardware solutions to CNC machine and robotic OEMs, which allows them to control the CNC machines via industrial automation. And here you can see an example of just some of the additive deposition operations available in Siemens NX. NX provides multi-axis additive manufacturing operations such as planar slicing. You might use this on simpler geometry. It allows slicing in any tool axis. Rotary functions for creating additive operations on circular or revolved shapes. Freeform additive for slicing parallel to any 3D complex shape. Freeform thin wall for complex but thin parts, such as impeller blades, again, for example. Tubes with constant wall thickness, think of an exhaust manifold. Tubes with inner structures and non-constant wall thicknesses are also supported. And there's even dedicated operations for complex coating onto freeform shapes, often used in repair work or laying composite layers. We also have toolpath merge functionality, so sort of like shuffling a deck of cards. This allows you to, resort the sliced layers of multiple bodies for optimum buildup. You can combine subtractive CAM operations with your additive manufacturing to complete the manufacturing process. A fully integrated CAD, CAM, and additive manufacturing system is required to do that. Utilizing one user interface with powerful 5-axis functions allows you to do machining operations anytime within the additive process. Whether you wish to machine after every individual level of additive manufacturing, utilizing a build, cut, build strategy. You can machine individual features once they are built. You could machine mounting locations, for example, if you need a certain area of the part to be smooth for mounting another part. Or you can machine the entire part at the end of the additive build. You have the flexibility to do what you want, when you want, and it's all within a common user interface with associativity. And why is that associativity so important? So the ability for the CAD to speak to the CAM, and the ability for the CAM to speak to the additive manufacturing software, etc. Well, if there are disconnects between the company's CAD, CAM, and CAE software, this will inevitably require data transfer and data re-entry, which would add time to the digital process. This also potentially introduces errors, and it's much harder from a data management viewpoint. So the net effect of a disconnected multi-axis additive workflow is inefficiency, And that inefficiency might outweigh the benefits of implementing a hybrid solution to begin with. So it's very important that you can stay efficient in the CAD to CAM to CAE to additive manufacturing workflow. You want everything to be as quick and easy as possible. The fact that the Siemens solutions are seamlessly woven into a greater end-to-end additive digital thread is fantastic. Without this connection, companies will be introducing inefficiencies into their process. So you can see we do everything from order management to generative engineering to additive build preparation, build process simulation, additive manufacturing scheduling, manufacturing execution systems, right down to quality and analytics if you want it. From procurement to product development to manufacturing planning and production, it's all connected on one end-to-end digital thread. And now we can take a look at a couple of case studies. So Big Metal Additive is a leading large-scale metal hybrid additive manufacturing machine maker, and they're also a service provider. Big Metal Additive is based in the USA. They have an integrated software workflow for producing high quality and large industrial scale hybrid additive manufacturing aluminium parts. What makes Big Metal Additive stand out from its competition is the size of its build volume, a 6 by 12 foot table, and they also have a very high deposition rate. So in one project for the military, Big Metal Additive was challenged to assess whether it was feasible to use their machine to build a cargo transport near its point of need. They wanted to see if they could do this faster and with less materials than the conventional manufacturing method. So Big Metal Additive used Siemens multi-axis additive software to plan and execute its hybrid additive toolpath strategy. And the result was a cargo transport with the passenger seating base you see in the image that was built from a 70% smaller bill of materials with an 80% faster lead time, leveraging a part design that couldn't have been achieved without large-scale additive manufacturing. So they topology optimized the part in Siemens NX, and they also applied all of the additive deposition toolpaths and all of the programming for their robots in the one end-to-end environment. Another little case study is from Akuma. Akuma is a machine tool builder based in Japan. Akuma sells a line of hybrid manufacturing laser deposition machines called Laser X. And to showcase the power of these new machines and the ability of NX CAM to efficiently manage additive and subtractive toolpath programming, Akuma produced a combustion case for an aircraft generator. Akuma used a software support solution called the Machine Tool Support Kit, or an MTSK. And an MTSK allows you to easily connect NX to a machine, which allows you to really quickly and efficiently do all of your programming and all of your virtual verification. And this results in an out-of-the-box machine programming solution that greatly reduces the number of CNC steps to produce a combustion case. So using additive manufacturing actually reduced the weight of the combustion case by 60%. Here at Kaizen PLM, we often help our customers to create their own custom MTSKs for their custom additive manufacturing deposition machinery. And our third customer story comes from Europe. So Seed is a technology supplier of 3D printing equipment from the Netherlands. They focus on large-scale composite additive manufacturing, and Seed were challenged to produce a radiator duct mold for a Formula One car out of carbon fiber and thermoplastics. And the goal was to use their new robot to perform an additive operation with continuous fiber additive manufacturing. and then a subtractive milling operation to smooth the part. So again, Seed, using our software, they could plan and execute the single robot toolpath strategy and simulate the robot's operation. They also used a Siemens Cinemeric controller to drive the machine. Seed dramatically accelerated the typical composite production process. It took just 20 minutes to set up for the machine and 8 hours for 3D printing. So now I'm going to briefly take you through the process of how NX is used for build program preparation, upfront visualization during toolpath generation, and emulation of the program and G-code generation. This helps the user achieve first time right printing. So in this demo, you can see the user navigating the operation navigator in the NX environment. Once they're in the operation navigator, the user is deleting the current robotic additive setup. Now he is retrieving a machine from the library and selecting the Kamau robot cell. Now that the Kamau cell is loaded in the NX environment, the user needs to add the seed extruder or any specific end effector from the machine tool library. You can save these setup templates for your specific company, so when you start NX, all of this can be pre-configured and saved for your exact setup. So once you do this once, you don't need to do it again, and you can save a template specific to your company's requirements. Once the tool is added, the user can then go to the assembly navigator and select the part which they want to 3D print, like you would select any other CAD file for 3D printing in any other software. And you can see the position of the part can be very easily manipulated with Triad. So now everything's set up, and it's time to use the wave geometry linker, and that can be used to link the base into the part file. This will define the initial condition of the print. An operation can then be selected with the operation navigator. So NX enables the definition of various deposition settings, and it allows you to select various operations for different strategies to suit your part. All toolpath settings can be modified as appropriate, such as layer thickness, etc. Non-cutting operation parameters can also be set. And once the settings are applied, the user is ready to simulate the machine. So you can see the user is applying an additive feature to the part that's been brought into the build preparation environment. The user is selecting what tool will be used for the additive operation. All slicing and output axis settings can be controlled, and you can save defaults which are typical of your specific setup. And all parameters like layer thickness, pat overhang, finish passes, non-cutting moves can all be controlled in the settings. So then it's time to simulate the additive operation with the specific multi-axis deposition setup. In this case, it's a 6-axis robot with a polymer extrusion head, but it could also be a 6-axis robot on an external linear axis. It could be on a vertical axis. It could have a tilt turntable underneath. Lots of different configurations are possible. By identifying potential issues and errors early in the design process, robotic additive deposition simulation can help reduce the need for any costly physical prototypes or testing. The simulation can also help optimize the robotic arm's movements and reduce the risk of errors or collisions, resulting in more efficient additive operations. So I hope that gives you a little overview of Kaizen PLM, how we help support companies with multi-axis additive deposition. And if you have any questions or requirements to get up and running with offline multi-axis programming, or any questions at all, feel free to reach out, send us an email, info@kaizenem.co.uk. Thanks very much for having me, and I hope the talk was insightful. Have a good rest of the day.